Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, my friends, to my YouTube channel Drilling and Workover. This is Abdelaziz Gabr. I am accredited instructor for IWCF Well Control and IADC Well Sharp. Also, I am accredited instructor in IADC Mod Engineering for Basic and Advanced Mod School. Today, inshallah, we will finish the course of the basic and advanced mod school. We will talk some questions about the basic mod school, which you may be asked in an interview in any mod engineering company, and also the advanced will be in the next session, inshallah. Okay, so this is very important lesson. So please pay attention to all these questions that we will talk about. The first question is to choose from the multiple answers. Okay, choose the best answer. Number one, sedimentary rocks like shales are, as I told you, the shale is the shales are porous and non-permeable. The shales are very porous, but it is non-permeable. So the best answers here are number B and number C. Okay. Number two, sedimentary rocks like limestone. Limestone. As I told you, the limestone is porous and very permeable. Okay. Why it is highly permeable? Because its permeability is through fractures or through something is known as solution or chemical porosity. Okay, not like the classic one. So number two, it is porous and permeable. Question number three, what is the required mud weight in PCF? Okay, in PCF to drill formation with the following data. MD, which is the measured depth, is 8,300 feet. Inclination is 50 degree. True vertical depth is 5,200 feet. Formation pressure is 3,000 and overbalance is 300. So it is very simple question. You will add 3,000 to 300. Okay, and you will use the law P equal 1 by 144 multiplied by the mud weight in PCF multiplied by the true vertical depth in feet. Okay, and from the equation you can get the mud weight. It will be about 92 PCF. Okay, differential stuck cannot or can't occur. This is very important question I have already asked when I was making interview. Okay, differential stuck cannot occur in, okay, it cannot occur in shale. Why in shale? Because the differential stuck need a permeable zone, a high filter cake, an overbalance, and also thick filtrate, high filter cake, thick filter cake, and filtrate. Okay, so it needs a permeable zone. So the permeable zone is the limestone. So it cannot happen in the shale because the shale is non-permeable zone. Number five, the ability to suspend the cuttings while circulation. While circulation is the function of fluids, the yield point. Why it is the yield point? Because this is from the definition. It's the ability to carry the cutting or the cutting capacity during circulation. But if it is in the static condition, it will be the gel strength. So take care about this. This is very important. The yield point is the ability of the cutting of the mud to suspend the cutting while circulation. Okay. Number six, for good hole cleaning, the slip velocity of the cutting must be more or lower or equal to the annular velocity. Actually, for good hole cleaning, the annular velocity must be more than the slip velocity. So here, the slip velocity of the cutting is lower than that for the annular velocity in order to get the cutting out of hole. So number B is the right answer. Number seven, hole cleaning for vertical well depends on the hole cleaning for vertical well. As I told you, we have in the whole cleaning two matters or two categories, the vertical well and the directional or horizontal wells. As I told you, the vertical well, it depends mainly on the high viscosity or in the yield point. So it depends on the rheology, mainly on the rheology. But in directional, which is the second question, okay, the whole cleaning for directional drilling, it depends on the value of the low shear yield point. It must be equal to the whole size. And the 6 RPM reading must be 1.5 one and a half of the whole size. Okay, and also it depends on taking tandem bells from time to time, low vis high weighted bell in order to make good hole cleaning. So number 7 for vertical is just the yield point, but number 8 for directional drilling, it depends on the B and C, which is the low shear yield point and the tandem bells. Okay. Number 9, good hole cleaning. Good hole cleaning for directional drilling, okay, of the well depends on the yield point equal to hole size or low shear yield point or what is known as Z factor equal to hole size or the gel strength equal to hole size. Actually, the best answer is number B. The low shear yield point must equal the hole size. Number 10, note is the mechanical friction in the drilling fluid. This is from the definition. It's the plastic viscosity. Plastic viscosity, which is any substance strange in the formulation of the mud. It gives the mechanical friction. Like, for example, water in oil-based mud. It is not homogeneous. Like solids in the mud. It is not homogeneous. So it gives the mechanical friction, which is the plastic viscosity. Number 11, the plastic viscosity is always higher or lower than or equal to than the yield point in the oil-based mud. Normally, the plastic viscosity must be higher than the yield point in the oil-based mud. Why? This is very important question. Why? Because the water in the oil-based mud, it acts as a solid or it is non-homogeneous with the diesel, so it gives high plastic viscosity. Number 12, the plastic viscosity is always not equal, than the yield point in water-based mud. Plastic viscosity is lower than the yield point in the water-based mud. Okay. Number 13, it's a well-controlled question. Gases are soluble or non-soluble in the water-based mud. Actually, it is non-soluble in the water-based mud. Number 14, well control is hard to detect in oil-based mud. Why? In oil-based mud, due to the water salinity? No. Due to the lime content? No. But due to the gas solubility. The gas solubility, and you will not detect the kick unless the gas expands and become at the surface. So this is very important question in the well control. Number 14. Number 15, the filter cake in drill in fluids. Drill in fluids is, as you know, the drill in fluids are used in the reservoir. So one of the characteristics of these fluids is to have very thin and impermeable filter cake. So number C is the right answer. Okay. Number 16, funnel viscosity of water. Funnel viscosity of water is plus or minus 26 second per quart. Okay, so the number B is the right answer. Number 17, the yield point for reading of the 6 RPM equal 56 and the reading of 3 RPM equal 40. Actually, how to calculate the yield point? Yield point equals the RPM, the 300 RPM minus the plastic viscosity. Okay, but the plastic viscosity equal the 600 RPM minus the 300 RPM. So this question, BV equal 56 minus 40 equal 14, and the yield point equal 300 minus equals 16, sorry, and the RPM of the and the yield point will equal 300 minus the BV, so it will be 40 minus 16. It gives 24 pound per 100 feet. Okay, this is very important. The yield point. Number 18, in case the reading of 6 RPM is 12 and the reading of 3 RPM is 9, and so that the gel strength will equal the gel strength for 10 seconds equals 6, 10, 8, 7. Actually, I told you that the gel strength, to get the gel strength, you get the maximum deflection at the 3 RPM, so that you will choose any number more than 9. So here it will be the 10, okay? But because if it is less than the 9, it will be wrong answer, okay? Because you take the maximum deflection for 3 RPM. Here it's 9, so any more than the 9, it will be number B. Number 19, in case the reading 6 RPM equal 12 and the reading 3 RPM equal 9, so the low shear yield point, or what is known as the yield or the Z factor, okay, will equal, it equals 2 multiplied by the RPM 3, okay, minus the 6 RPM. So it will equal 2 multiplied by 9 minus 12. It will give you 6 only. So number A is the right answer. Okay. Number 20. Number 20. No. What is here causes formation damage in the reservoir interval? Okay, you can choose calcium carbonate. No, it is acid soluble. Calcium chloride, it's a brine and it is used only. It is used also. There is no problem. Sodium chloride, it is also brine, so it is not a big deal. So the answer is barite, because the barite is non-soluble material. So number 20 or 20, the right answer is barite. Okay. Number 21, silicates are insoluble, generally insoluble, okay? Number 22, in makeup water process in water-based mud, calcium disposal can be done by adding, okay, this is very important question number 22. As I told you, the calcium is cationic and it has divalent, so Ca plus 2. So in order to get rid of this calcium, we need to add something which gives minus 2, okay? So what gives minus 2 is the carbonates, CO2 minus 2. So that what is the chemical which contains the carbonates? Actually, it is the soda ash, which is Na2CO3. So number 22 is to get rid of the calcium by adding the soda ash. Number 23, in makeup water process in water-based mud, the magnesium, okay, magnesium Mg plus, okay, or plus 2, disposal can be by adding the caustic soda. The caustic soda, okay, is the right answer. Number 24, pH increases with increasing the hydroxyl group or hydroxide group. So number C is the right answer. The pH increases by adding a hydroxide group. Number 25, the type of water-based mud that needs high pH is, as I told you, the KCl polymer, okay, it needs high pH, but it is 9, just 9. Spud mud, just 9. BHBA needs low pH. BHBA needs low pH, okay, it's plus or minus 8. But the silicate mud, it needs about 12. 12. So the water-based mud that needs a high pH is the silicate mud. Number 26, the type of mud, of water-based mud that needs low pH is the BHBA, okay? Number 27, the maximum concentration of the KCl for inhibition is, in some references, it can be up to 7%, but in the most common, the maximum one is 10%. So the maximum concentration of KCl for inhibition, it's about 10%. Number 28, the end point of phenolphthalein for filtrate is at pH 8.3. Okay, take care of this. The end point, and the end point for the BF, when the color it changes from the what is known, from the pink to become colorless. Okay, here in the BF the color changes from pink to be colorless at pH equal 8.3. Number 29, the endpoint of the MF or methyl orange for filtrate is at pH. Okay, the methyl orange or the endpoint, it changes from the orange to become wine red. To become wine red, it will be at 4.3. Okay, the endpoint of the PM or phenolphthalein for the mud is at pH also 8.3. Okay, so take care of all these numbers. Number 31, the maximum concentration of the low gravity solids, in order not to make a big problem for the solid content in the mud, is about 55%, 5%. Okay, in oil-based mud, what is important to overcome the acid gases? Actually, the acid gases, it needs something alkaline. What is the alkaline? The alkaline has OH group or hydroxyl group. So which component of these has the OH group? Actually, it will be the excess lime, because the lime has very high content of OH group or from hydroxyl group. Number 33, the MBT test measures MBT test. What it measures? It measures the clay content or the active clay content in the water-based mud. So number C is the right answer. Number 34, corrected solids. What is the difference between the corrected solids and the retort solids? Actually, the corrected solids equals the solids minus the salt which is dissolved in the mud. Okay, so here the corrected solids are calculated by subtracting the salt from the total solids. Okay, number 35, what causes formation damage in the reservoir interval? We have see this, it is barite, it is repeated question. The type of mud which contains low solids and have high mud weight. Okay, it is known as the formate mud. It is the formate mud. Number 37, polymers used in drilling high P, high T wells are not thermally stable. Okay, so we add a chemical for the thermal stability. As I told you, it's called PTS12. PTS12, which is a polymer used, or it is in drums. Okay, they are added to make polymer stabilization for temperature. But code 514, it is used for the diesel inhibition. Bactrum 55 is used for the bacteria, and also code 1400 is for brine or water inhibition. Okay, so PTS 200 is the best answer. Okay, all these polymers can be added to silicate mud system. Why to add to silicate mud system? Because the except, okay, sorry, all these polymers can be added to the silicate mud system except the PHBA. Why? Because all of these polymers needs high pH, but the PHBA it needs low pH. Okay. Methods of solid control techniques. It can be by settling, by dilution, mechanical separation, chemical treatment, or all of the before. The right answer is number E. Cement can be drilled by adding to the water-based mud. As I told you, cement, okay, cement, um, it increases the pH and increases the calcium and also it increases those two problems. So in order to get rid of the calcium and of the pH, we can add citric acid or sodium bicarbonate or what is known as subpolymer. Okay, sodium polyacrylate or something like this. It's subpolymer, SAAP, or all before. Okay, so all before is the right answer. Number 41, carbonates contamination can be treated by adding. Carbonates is CrCO3 minus 2. Okay, so in order to get rid of the carbonates, we have to add something plus 2. Okay, so that they can settle. What is the C? That's what is the element which has plus 2? Actually, it is the calcium. So the calcium here, the carbonates can be carbonate contamination can be treated by adding lime, which contains a lot of calcium. A lot of calcium. Okay. Number 42, carbonates contamination. Carbonates contamination indicates high alkalinity, no calcium, progressive gel, all of the before. Okay, so the best answer is all before. Number 43, the gas H2S gas effects on the water-based mud as following. Okay, it makes the mud to be black, it gives black drill pipe, and it decreases the pH. So the best answer is A and B. Okay. Solids can be treated by using, okay, all of the before. You can make dilution, solid control, add thinners. So it is all of the before. Number 45, water contamination in oil-based mud can be treated by adding. The water contamination in oil-based mud can be treated by adding diesel, lime, and first emulsifier or primary emulsifier. So D is the right answer. Increasing number 46, increasing of the low gravity solids is due to the increase in MBT, yes, commercial chemicals, yes, drilled solids, yes, so all of the before. Number 47, the optimum operation for the shale shaker assumes the drilling fluid to cover 70% of the screening area. All the screening area is not right answer. C is also wrong answer. So number A is the right answer. 48, optimum operation for the descender and the desilter is to have feeding pressure or feed pressure equals 4 times multiplied by the mud weight in the BBG. Okay, so in PSI equals 4 multiplied by the mud weight in BBG. So this is the best answer. Number 49, centrifuge system that is used for barite recovery needs at least 2 centrifuges with different RPM. As I told you, one of them to get rid of the low grade, to be separated, to separate the barite at 1600, okay, and 1600 RPM. Then it takes the barite to the system, and the other mud is taken to the second centrifuge where the low gravity solids can be separated. Okay. And I have told you that those 2 centrifuges are adding in row, not in parallel. The final question, number 50 in this part, okay, number 50, anhydride formation leads to decrease in, it decreases the pH, it decreases the pH, okay, it decreases the pH. Uh, Thank you today, my friends, for this lesson. It is the first lesson in the questions. I hope, inshallah, we will continue for another one. And please revise it again and again for these questions. Thank you very much and see you later in the next lesson, inshallah. And goodbye.